today we're going to be talking about graphing absolute value. Now, very similar to graphing lines, which is what we did last week, but just a little different because the shape's not the same. Okay? So it's up to you if you want to take all of your notes on the graphing sheet. There'll be plenty of space for that. If you want to do some in your notebook or your newspaper, and then just graphs on the graphs, that's up to you. I don't care. Okay? But I do see that I got to get more candy. Okay, so this first graph on this next slide is just a picture. You don't need to. Remember how I said you weren't going to be the one? Remember? We had that conversation? All right, so this next graph is just the parent function. Don't put it on your graph because we have 4 examples of graphs to do it. I want you to have a clean one on each one. Okay? All right? So this is just what an absolute value function looks like. We call it the parent function. Some people call it the mother function. Okay? All right? Exactly, because that's why people call it the mother function. Okay? But it's really called a parent function. Okay? So an absolute value graph looks like this. This is the basic absolute value graph. F of x equals, or y equals absolute value of x. What pops up for you? What pops for you? It's a v, okay? Which is super duper easy to remember, right? Because value starts with v. Okay? So an absolute value graph is a v. Okay? Now, it can be a right side up v, or it can be an upside down v. We'll get into that momentarily. Okay? But it's a v always. It is not an x. It's a v. So this intersection change type point place right there, we call that the vertex. And yes, I am air quoting the vertex because I forget what the technical name is, but it's like 18 consonants long. And then there's a vowel, and then there's like 28 more consonants. Okay? I just call it the vertex because it kind of has the same properties as a parabola, and that point on a parabola is called the vertex. Okay? Those properties are, it's symmetric, they're both going in the same upwards, downwards direction, etc., etc., etc. Okay? So that's what the parent function looks like. Okay? Now, we are going to explore 2 different ways of graphing, or of getting this graph. The first method is, it works. Okay? It's just that it works. Is it my favorite? No. Okay? Is it the easiest? No. But is it your fallback just in case you forget all of the other parts of the other one? Oh yeah, big time. Okay? And that is graphing an absolute value with a t-chart. Okay? So, how we go about doing that, graphing an absolute value with a t-chart, the first thing that I am going to do is I am going to pick, and I just literally chose 5, just because 5 was a number. That's how many fingers I have on one hand, so that's why I went with 5. Okay? My uncle would choose 4.5, because he's missing half of a finger. Okay? Okay? So we're going to pick 5 random x values. I don't care what they are. I don't care where they go. What x value you choose. Okay? I would be, however, somewhere between -10 and +10, because that's what your graph is. Okay? So I wouldn't go, like last class chose 32 as an x value. Like, off the graph, choose again. Okay? Then what you're going to do is you're going to plug those 5x values into the equation, and you're going to get the y value. So you're going to do the math on those 5. And you got to do it differently on each one of those 5. So once you got those 5, then that's going to give you 5 points that you can plot on your graph. Okay? So you're going to plot those 5 points on your graph. Now, here's the downfall of this chart. Okay? After you plot those initial 5 points, if you can see the vertex, okay? So can you see that V or that mountaintop upside down? Okay? If you can see those, okay, if you know where it is, you get to go to step number 3. If you don't see it, then you gotta go back to step number 1, and you've got to try more points until you know where that V is. Okay? And you got to keep doing that until you find that V. Now, for some people, that might be, they might get it right off the start. For some people, it might be 6 or 7 points in. For some people, it might be 15 to 20 points in before they find it. Okay? Because you got to kind of find it. You know what I mean? Then, once that's all said and done, then you can connect your V. You can make your V with 2 rays. Remember, a line goes on forever in both directions. A ray only goes on forever in one direction. Okay? So you make your V or your V. Okay? Not a line. Let's put that to work. Let's do this problem. Okay, so now for sure we're on the graph. Y equals the absolute value of x minus 2, then plus 3. So I need, my first step said, I need to pick 5 x values. Okay, so I need 5 numbers. 0, negative 1, 1, 4, 5. Sure, works for me. Okay. 5 random ones. Now what we've got to do is we've got to plug those values back into our function. So 0 minus 2. 0 minus 2 is negative 2, absolute value of negative 2. 2 plus 3, 5. So that gives me the point 0, comma 5. Then I go to negative 1. Negative 1 minus 2. Negative 3, absolute value. 3 plus 3, 6. So that's the point, negative 1, comma 6. 1. 1 minus 2. Negative 1, absolute value. 1 plus 3, 4. 4 minus 2, 2, absolute value, 2 plus 3, 5 minus 2, 3, absolute value, 3 plus 3, 6. we'll go off of color. Are any of those our vertex? No. So we haven't found the vertex yet. Do I know roughly where the vertex is? Where do we think it roughly is? At 2, 3? Okay. So let's plug in 2. Oops. Let's try 2 here. If I do that, absolute value, so 2 minus 2 is 0. Absolute value is 0, plus 3 is 3. So that would be the point, 2, 3. And does that make that V? Yeah, because in my brain I'm thinking, okay, these two are on one side, I got to connect, it's got to come down. These 3 are on one side, it's got to connect, it's got to come down. Shabam, there it is. Now we can draw it in. Okay? So we draw it in using our wonderfulness, that is our straightness of a ruler or a ID or a edge of paper, something like that, and we draw in that. Okay? Always works. My favorite? No. What it always. The other way of doing it is using the transformation method. So the basic, or I shouldn't say the basic, the transformative function for an absolute value is y equals a times the absolute value of x minus h, then plus k. Now, the transformations that can happen with a V graph is we can move it up or down. We can move it left or right. We can make it be really skinny. We can make it be really wide. Or we can flip it over. Or we can do multiple combinations of those things. Okay? So all of that happens based off of those 3 letters, A, H, and K. Okay? So A is a big time component of it. So A will make our graph skinny or wide. If A is bigger than 1, it will be skinny or narrower. If A is less than 1, it will be wide. A also makes the graph open up or down. If A is positive, it will open up. If A is negative, it will open down. So all 4 of those things come just out of A. H moves our graph left and right. An absolute value, just for your knowledge, an absolute value is a grouping symbol, like parentheses, brackets, etc. it's coming. I can still feel it build. Okay? H, because it is inside a set of grouping symbols, we need to think oppositely. Meaning, if it's x minus h inside the absolute value, that's actually a right shift, even though right is the positive direction. If it's x plus h, we shift it to the left. And that will come up numerous times throughout the course of this entire year. That opposite thinking inside a set of parentheses or a set of grouping symbols. Okay. K is outside, so we don't have to think oppositely. And so that's going to be a straight up thinking, move it up, move it down. If K is positive, it shifts up. If K is negative, it shifts down. Okay?
So let me bring this down and then this here, and then put this to there, so that on one slide I can bring this now up to there and then shove down. Okay?
So the nice part is the vertex is found right from the problem, and that vertex is, ooh, that's a bad K, is at H, comma, K. But again, with the H, we have to think opposite. So if it's minus 4, that's really an H value of positive. So let's do the exact same graph that we just, oops, I forgot steps to solve it. Okay? So the steps are really easy on this one. So the first one is you're going to plot, or you're going to find the point H comma K. And you're going to plot that point because that's your vertex, that's your starting point. Okay? Again, thinking oppositely about H. Then, this part is really, really nice. Okay? That A value out in front of the absolute value, that A value is the slope of the right side of your V. Okay? As written, that's the slope of the right half of your V. The left half of your V is negative of that. Okay? So you have everything that you need. No need to go plot points at all because you've already got everything that you need. And then again, you connect the points with two rays. Not an X, it's a V. All right. Now let's put this to work. Okay? So we're going to do the same problem. So did I go too quickly? My fault. Stop yelling at me, Steve. So yes, I know it's the exact same problem that we just did, but we're going to do it again. Now this time with the H comma K method. Okay. So when I'm looking at this function, which you've already graphed, you graphed it above. Please graph it again on the second graph. Okay. I look at this number here, and that's my H. I look at this number here, and that's my K. But on this one, I think opposite. So my vertex is at the point should be -2, because that's what I see, but I think oppositely, and that's +2, comma 3. So I can go right to that point, 2, comma 3, and I can put my dot right there. Then, this number out in front here is my right side slope. If nothing's written there, then we're just assuming it to be 1. So my right side slope is +1. So that is an up 1, right 1. Up 1, right 1, up 1, right 1, all the way through. My left side slope is going to be the negative, the opposite of that, if you will. So that's going to be negative. Now, normally on a negative slope, you go down and to the right. But that's not going to make me a V, right? That's going to make me a baby shark, do, baby shark, do. Okay? I don't want baby sharks. Okay? I want V's. So instead of going down and right, I'm going to go up and left. And that gives me the V that I need. Okay? Questions on that? Now, does it matter to me which method you choose to do your actual graphing? No. No. Whichever way you feel better, you feel more confident in, you do you, I'll do me. Okay? 2 more examples to do yet today. Okay? So I would obviously first, like you to write down the function or the equation right next to your graph, so then that you know what you're dealing with. So that should happen at all times. But then, yes, please graph this absolute value function. But so where is the vertex? -6, comma 7. So that's left 6, up 7, right there. Okay. What is my right side slope? -1/4. As written, it's the A value. So that's down 1 and right 4. Down 1, right 4. Down 1, right 4. Down 1, and right 4. Okay. What is my left side slope? +1/4. But I want to go up and right or down and left. Down and left, right? Because I want a V. I don't want grandma shark or grandpa shark, whichever one. Then we can draw it in. And we're good to go. Okay? Love it. Try that one. Vertex. 3, comma -4. So that is right 3, down 4. Right side slope. 1/2. That's up 1, right 2. Up 1, right 2. Left side slope. -1/2. Up and left. Yeah, buddy? Tomorrow, what we'll do is we'll do day 2 of this, so we're gonna work in reverse tomorrow. I'm gonna give you the picture, you give me the graph, or you give me the equation. Okay? And then we're gonna have another day of writing equations like we had from, not yesterday, that other day, Monday. Okay?